Good afternoon, and welcome to the start of what I can consider the real calculus part of the class. I'm going to start talking about derivatives finally. So, what is a derivative? It simply is the slopes, or multiple, of the tangent lines as they change along a curve. So, if you remember earlier, we talked about secant lines, where we picked two dots and connected them, found their slope. Well, we talked then about how if the 2 points we're using for our secant line get closer and closer to closer, we eventually get what's called a tangent line. And again, those tangent lines are spots where it hits the curve in just one location. So you can see on the left-hand side at the green one, you can see there's a dot and a tangent line drawn, and we can see the slope of that line is negative. Because at that specific moment in time, if this was a graph on time, that specific moment, the graph is headed downward. Where on the right-hand side, the blue dot, at that spot, the tangent line is clearly positive, meaning at that particular moment in time, our graph is moving in the upward direction. It's really all that a derivative tells us. It tells us the direction that a graph is moving, whether it's a positive or a negative, and then how quickly or slowly it's moving. So we're going to be writing the equation of that tangent line today. That's going to be our job. And we're going to use derivatives to do this. So first off, the rate of change for a tangent line. So we've got some function, f of x, on an interval from a to x. And again, we want that interval to keep getting smaller and smaller and smaller. We want x to keep getting closer and closer and closer to a, so essentially they're the same number. That would give us our tangent line. All right, so that slope of the tangent line, and that's what this notation here means, the slope of the tangent line. That's not actually any work you do with the word tangent, it's just telling you what you're finding slope of, is the limit as x approaches a, again, trying to get closer together. And then this right here should look familiar. This is the difference quotient that we talked about last chapter. All right, so we'll be using that all over again. Now, the equation of a tangent line at a comma f of a. And essentially, this is just a fancy way of saying that's the answer, and this is the input. So if you remember x1, y1s, and a little bit of that leads us into what our equation is. The y minus f of a, which is really your y1 coordinate, equals the m, the slope of the tangent line, and then x minus a, which is your x1 coordinate. And that should look familiar because that's point slope form. So seeing some Algebra 1 pop into our work today. Alright, so let's try an example. And it gets a little bit messy, but we're going to work our way through it. So we've got this function. It's a parabola, negative 16x squared plus 96x. I don't know if you remember or not about parabolas from Algebra 1 and 2 and a little bit in pre-calc last year. We talked about this negative 16. That's the gravity of Earth. This is for projectile motion, so something's being launched into the air from ground level and landing back on the ground later on. And that's this number here is, I believe, our initial velocity, 96. All right, so we're going to find part A, we're going to find the slope of the tangent line at 1, 80. So essentially what we're looking for is we want to know the equation of the tangent line that goes right past that point right there. All right, so there's our point, 1, 80. And we're going to write the equation of the tangent line. That's our second part. So in A, or part A, finding the slope, we have our A number being 1. Again, A is essentially on the x-coordinate number. And we got that 1 right from that ordered pair there, 1, 80. That's where the answer A came from. So we're trying to now take another point x and bring it closer and closer and closer. That's this difference formula, or difference equation here. All right, so let's go ahead and plug in some of our parts. All right, so the first thing, we've got f of x, this part right here, which means essentially we're going to just rewrite the original equation in that spot. So that'd be negative 16x squared plus 96x. And then we're going to minus f of 1. That means we're going to actually put 1 into that equation where the x is and calculate out an answer. So that means negative 16 times 1 squared plus 96 times 1. And if you do that, you end up with 80. And then denominator is x minus a, or in this case, a is 1. Alright, so let's clean this up a little bit. Let's put some terms together in that numerator. Nothing really matching there. Ooh, that's a terrible 80. And what we want to do is we want to cancel some things out with that denominator. Because the issue is, again, we want to not have that x minus 2 denominator. That could be a potential problem. We could end up with a hole or an asymptote or something there. So it'd be nice if we could cancel that out. So it's going to require a little bit of factoring, and a little heavier factoring than I'm going to give you on your problems today. But I could factor a negative 16 out of that numerator, giving me an x squared minus 6x plus 5. And then I could factor out that trinomial there, giving me an x plus 5, whoops, not x plus 5, my fault, x minus 5, x minus 1. And then we can see we get some canceling. So at this point, what we know is the slope of our tangent line is equal to the limit as x approaches 1, because we're trying to get close to 1, for negative 16 times x minus 5. So we're going to plug that 1 in, which will give me negative 16, and then 1 minus 5 is negative 4, and I got 64. So I now have the slope of my tangent line. So I'm going to plug that into my point slope form. Y minus, remember our point we're looking at is the point 180. So my y minus y1 number would be 80. The slope of my tangent line, I just found it is 64. And then x minus my x coordinate. So that's my point slope form. Now I can multiply out my parentheses and then add 80 on both sides. And I now have the equation for the tangent line at that particular point. Right, so that's our job. We're trying to find the equation of the tangent line at a specific point. So it required, again, 2 steps. First step was that difference formula, or a difference quotient we learned earlier in the chapter. All right, we had to fill some stuff out there. And again, I gave you a little bit easier factoring in your assignment today. And that gave us the slope. We got 64. And then we used that slope, and then that original point we were investigating, and used point slope form, reduced it down to slope intercept form,